Hi everyone, welcome to this self-check 1.1 exercise video. Let's go over these problems. So for each of the following relations, give the domain and range and indicate which are also functions. Okay, so let's check out number one. So we're just given a bunch of kind of coordinate points. So let's go ahead and list them out in their respective domain and ranges. So remember, these are like x, y, x, y coordinate points, and X is domain, and Y is range. Okay, inputs and outputs, input, output. Okay, so just some review on that. So let's put them in a respective domain. So domain is our X values. So I'm going to put them in some type of set bracket here. And so it will just be 2, 3, 1, and 0. Okay. And our range would be 5, 4, 4, and 6. Okay. So remember, for a function, in order to be a function, each input must only have one output, right? It's okay for an output to have multiple inputs, but every input must have one output. So if we look at our domain here, our domain, right? Every input just has one output. We're not doubling up here at all. So there's no repeating x values. So that makes this a function, right? Each input has one output. So yes, a function. Okay, so let's look at the next one. So same thing. My domain will just be my x values. So 0, 1, 2, and 1. But here we're kind of repeating 1. So we can just reduce that to 0, 2, and 1. Okay, so likewise, let's check out the range. We'll have 4, 6, 4, and 5, but we're repeating 4. So it'll just be 4, 6, and 5. So that's our domain and range. Okay, so maybe I could highlight 1 and 1, and then 4 and 4. So it becomes that. Now let's check out if it's a function. Now remember that every input has to only have one output. So if we look here, the input 1 has two different outputs. The input 1 has an output of 6, and it has an output of 5. So this makes it not a function because every input must only have one output. So here we'll say not a function. Not a function. The input x equals 1 has multiple outputs, y equals 5 and 6. Okay, so that's how you would do that one. Let's keep moving forward. So find the domain and range of this function. So remember, domain is x values. So domain, x values, what's the smallest x value you can go? And the largest x value you can go. So you really kind of just refer to your x-axis right here. That's what I typically do. And what's the furthest left you can go? What's the smallest you can go? Well, it looks like this graph stops at -4. That's the smallest x value you go. So what I would do here is I would just start off with -4. Okay, so now what's the largest x value I can get? What's the most right I can go? Well, it looks like here it's still just going to be 4. That's the largest x value I go to. So my domain would be 4. -4 to 4, hard brackets because, you know, it's included in the graph. It's a solid point. Okay, range. We're going how high to how low. What's the smallest y value? What's the greatest y value? So the lowest I can go, I'm following along this y-axis here. Smallest I go looks like -5 right here. Right? That's the lowest this graph goes. So what this would be is hard bracket -5. And likewise, what's the highest I can go? Well, it looks right here, it would just be +5. So -5 to 5. Okay, great. So let's keep moving forward. So we want to evaluate this function here. We have x squared plus 2x plus 1, and we want to evaluate it at these inputs here. So let's check out the first one. So f of -3, all we're going to do is just plug in -3. So it'll be -3 squared plus 2 times -3 plus 1. And then this will just be -3 squared is 9. 2 times -3 is -6 plus 1. And what this becomes is just 4. Okay, so that's how we do that one. And now here is where it gets a little more complicated, but just still treat it as an input. So we're going to plug in a minus 1 wherever there's an x. Okay, so what I like to do is go off to the side here and kind of multiply this out on the side. So a minus 1 squared just means a minus 1 times a minus 1. So they'll distribute in the a. So I get a squared minus a, then distribute the -1. Now we get minus a plus 1. So we would get a squared minus 2a plus 1. Okay, and then don't forget to distribute in the 2 here. Okay, so what we get here is a squared minus 2a plus 1 plus 2a minus 2 plus 1. All right, and we have some like terms here. So these guys cancel out. This is 1 plus 1, which is 2, and that cancels out with -2. So really what you're left with is just a squared. Okay, and that's how you would do that problem. Okay, let's keep moving forward. So number 5 is let f of x equals 1 over x plus 3, and we want to evaluate it at -1/2. So we're just going to plug in -1/2 into this thing. So f of -1/2 equals 1 over -1/2 plus 3. Okay, so what this becomes, let me kind of rewrite this. This becomes 1 over -1/2 plus 3. So we want to clean this up a bit. So what we got to do is find a common denominator. So what we would do here is 1 over -1/2 plus 3 times not negative, 3 times 2 over 2, right? We're trying to get the same denominator, 2. So what this becomes is 1 over -1/2 plus 6 over 2. Okay, so now we have the same denominator, so now we can add these fractions. So what we end up with is 1 over 5/2, right? And so remember when we divide by fractions, it has to flip. So 1 divided by 5/2, well, that equals 1 times 2 over 5. And that just equals 2/5. So that would be the answer for that one. Okay, almost there. So graph square root of x minus 2. So easy way to graph something, you just got to create a table and get your points. So x, y. And so I'm just going to pick some easy points to work with. Something I'll pick is 0. I don't want to pick anything that will give me an ugly number, like square root of 2. That would be an ugly number to get me. So pick 1. Some common on square roots. I'll pick 4 and I'll pick 9. Okay, so square root of 0 minus 2, well, that's just -2. Square root of 1 minus 2, well, that's -1. Square root of 4 minus 2, and that is 2 minus 2, which equals 0. And square root of 9 minus 2, that's 3 minus 2, which is 1. Okay, so got some points here. 0, -2, 1, -1, 4, comma 0, and 9, comma 1. Okay, great. So let's go ahead and graph this. All right, so we have y-axis, x-axis, and we really are only going up, 1, 2, 3, 1, 2, 3. All right, and we go all the way up to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's go ahead and just graph these points. So we got 0, -2's right here. We got 1, -1 right here. We got 4, 0 right here, and then 9, 1 right there. So it'll look something like this. All right, so it'll be g of x equals square root of x minus 2. We write that. Okay, so that's how you graph something like that. Just create a table, pick some easy numbers to work with. Okay, so last problem, graph the following relation and indicate whether the is a function or not. So same thing, let's go ahead and create a table. So x and y values. Okay, so this one's a little different, right? Because it's like x equals and not y equals, but you would kind of work backwards here. If I pick something like -2, I would get, you know, 3 minus, you know what, I'm going to flip this backwards. I would have y and x. So if I pick something like -2, I would get something like 3 minus -2 squared. So 3 minus 4, which is -1. All right. And then I would just do a couple more numbers. I would do like -1. So 3 minus -1 squared. That's 3 minus 1, which is 2. And then 0, 3 minus 0 squared. Well, that equals 3. And then I just do a couple more. 1, that'll be 3 minus 1 squared. And that would equal 2. If I pick 2, that'll be 3 minus 2 squared. And that would equal -1. Okay, so let's go ahead and graph this thing. Okay, so I would have something like this. All right, here's our y, our x, so on and so forth. So our y values really went up to like 2, right? So 1, 2, 3, 1, 2, 3. X values, go up to 3 as well. 1, 2, 3, 1, 2, 3. All right, so his first point is -1, -2. Remember that we kind of switch our x and y values. This point right here is 2 comma -1, 3 comma 0, 2 comma 1, and -1 comma 2. All right, so we have -1 and then -2 right here. We have 2 and then -1. We have 3 and then 0. We have 2 and 1. And then we have -1 and 2. So really the graph looks something like that. All right, so is this a function or not, right? So remember vertical line tests. This looks like it would fail the vertical line test because it's intersecting it at points on the graph, meaning one input has multiple outputs. And so this is not a function. So I would say fails vertical line test, not a function. Okay, so that is our self-check for section 1.1. Hope this helps understand the material. See you next time. Thank you. Bye.